Hello, welcome to my channel Speak with Math. Here I am discussing some problems in Laplace transform and I already posted a video in this topic. So please watch that video first, then only you will get a complete idea about this particular topic. The first problem is when n is a positive integer, find a reduction formula for L of t raised to n. And hence evaluate L of t raised to n. We have, by the definition of Laplace transform of t raised to n is equal to integral 0 to infinity e raised to minus st t raised to n f of t dt. Here, to integrate this function, t raised to n will come first and exponential will come second. So this becomes integral 0 to infinity t raised to n into e raised to minus st dt. This is equal to first function into integral of second, that is e raised to minus st divided by minus s, limits varying from 0 to infinity, minus integral of derivative of first function into integral of second function. Here we apply the upper limit, this function becomes 0. E raised to minus infinity is 0. It is limit t tends to infinity e raised to minus st is equal to e raised to minus infinity. When t tends to infinity, e raised to minus st is e raised to minus infinity is equal to 0. If you apply the lower limit, this term will be 0. So here it is 0. Minus of minus plus n by s into integral 0 to infinity e raised to minus st into t raised to n minus 1 into dt. That is n by s into Laplace transform of t raised to n minus 1. By definition of Laplace transform, L of t raised to n minus 1 is what? E raised to integral 0 to infinity e raised to minus st into t raised to n minus 1 dt. S greater than 0. So the required reduction formula is Laplace transform of t raised to n is what? N by s into Laplace transform of t raised to n minus 1. Now we have to evaluate what is L of t raised to n, that is Laplace transform of t raised to n, that is what? N by s into Laplace transform of t raised to n minus 1. By using the reduction formula, we can write L of t raised to n minus 1 as what? N by s into here t raised to n minus 1. So we get n minus 1 divided by s into Laplace transform of t raised to n minus 2. Here I applied the reduction formula. That is, replace n by n minus 1 here. So we get n minus 1 by s into Laplace transform of n minus t raised to n minus 2. That is n by s into n minus 1 divided by s into n minus 2 divided by s into Laplace transform of t raised to n minus 3 is equal to n by s into n minus 1 by s into n minus 2 by s, etc. 2 by s into 1 by s into Laplace transform of t raised to 0. Now Laplace transform of t raised to 0 is what? T raised to 0 is what? 1. That is Laplace transform of 1. Laplace transform of 1 is 1 by s. Here n into n minus 1 into n minus 2 etc. 2 into 1. That is what? N into n minus 1 into n minus 2 etc. 2 into 1. Here s into etc. that is s raised to n into Laplace transform of t raised to 0, that is 1 by s. So we get n factorial n into n minus 1 into n minus 2 etc. 2 into 1 is what? N factorial divided by s raised to n into 1 more s, that is s raised to n plus 1. So Laplace transform of t raised to n is equal to what? N factorial divided by s raised to n plus 1. Now, what is the second problem? Using the definition of Laplace transformation, prove that Laplace transform of t raised to a is equal to gamma of a plus 1 divided by s raised to a plus 1. The gamma function defined for a greater than 0, that is gamma of a is equal to what? Integral 0 to infinity e raised to minus x raised to a minus 1 dx, where a greater than 0. Gamma of a is equal to what? Integral 0 to infinity e raised to minus x into x raised to a minus 1 into dx, where a greater than 0. Now we have, by the definition of Laplace transformation, Laplace transform of t raised to a is what? By definition of Laplace transformation, integral 0 to infinity e raised to minus st into t raised to a into dt. Here we have to integrate with respect to t, and here it is with respect to x. So I am changing this integration, that is, let us t is equal to what? X. Then t is what? T is equal to x divided by x. Then dt is equal to what? Dx divided by x. When t is equal to 0, what is the value of x? T is equal to 0, x is equal to 0. When t is equal to infinity, x is equal to infinity. So Laplace transform of t raised to a is equal to what? Integral 0 to infinity e raised to minus st. St is what? X. So e raised to minus x into t raised to a, that is x by s the whole raised to a. T is what? X by s. T raised to a is x by s whole raised to a into dt. Dt is what? Dx divided by s. Here I change the integration from dt to dx. So what is this? 1 by, here s raised to a, and here one more s. So 1 by s raised to a plus 1 into integral 0 to infinity e raised to minus x into x raised to a into dx. E raised to minus x into x raised to a into dx. Now, what is integral 0 to infinity e raised to minus x into x raised to a dx? Compare this with the equation 1. What we get? 1 by s raised to a plus 1 into gamma of a plus 1. Gamma of a is what? Integral 0 to infinity e raised to minus x into x raised to a minus 1. Here it is what? E raised to minus x into x raised to a. So, gamma of a plus 1. X raised to a means gamma of a plus 1. X raised to a minus 1 means gamma of a. So, we get Laplace transform of t raised to a is equal to what? Gamma of a plus 1 divided by s raised to a plus 1 if s greater than 0. That is Laplace transform of t raised to a is equal to gamma of a plus 1 divided by s raised to a plus 1. Gamma of a plus 1 divided by s raised to a plus 1 if s greater than 0. Now, this is the required solution. Gamma of a plus 1 divided by s raised to a plus 1. Now, when a is a positive integer, gamma of a plus 1 is what? A is a positive integer, gamma of a plus 1 is what? A factorial. So, this equation becomes Laplace transform of t raised to n is equal to what? A factorial divided by s raised to a plus 1 when a is a positive integer. That is the solution of first problem. A factorial divided by s raised to a plus 1. Now, the third one is find the Laplace transform of the following functions using linearity of Laplace transform. What is linearity of the Laplace transform? Linearity of Laplace transform. If a and b are two constants, and f of t and g of t are functions with the Laplace transform, f of s and g of s, then Laplace transform of a into f of t plus b into g of t is equal to what? A into Laplace transform of f of t plus b into Laplace transform of g of t. That is, a into Laplace transform of f of t is f of s plus b into g of s. This is called the linearity of Laplace transform. That is, Laplace transform of a into f of t plus b into g of t is what? A into, a and b are constants, a into f of s plus b into g of s. Now, first one is cos at. That is Laplace transform of cos at. We have the Euler formula. That is e raised to I theta is equal to cos theta plus I sin theta. And we know that Laplace transform of e raised to iat. So I am changing theta to at, that is put theta is equal to at, then that equation becomes e raised to iat is equal to cos at plus I sin at. Now Laplace transform of e raised to iat is equal to what? Laplace transform of cos at plus I into Laplace transform of sin at by linearity theorem. Laplace transform of e raised to iat is equal to Laplace transform of cos at plus I into Laplace transform of sin at. And what is Laplace transform of e raised to iat? That is 1 by s minus ia. Just multiply numerator and denominator by s plus ia. What we get? S plus ia divided by a minus b into a plus b, that is s square minus I square into a square. I square is minus 1, so s square plus a square, that is s plus ia divided by s square plus a square. So Laplace transform of e raised to iat is equal to what? S divided by s square plus a square plus I into a divided by s square plus a square. I just split into two parts. S divided by s square plus a square plus I into a divided by s square plus a square. Now equating the real and imaginary part of these two equations, we get what? Laplace transform of cos at is equal to Laplace transform of cos at is equal to what? S divided by s square plus a square, and Laplace transform of sin at, that is here. I into Laplace transform of sin at is what? I into a by s square plus a square. Just equate the real and imaginary parts of equation 1 and equation 2. We get Laplace transform of cos at is equal to s divided by s square plus a square, and Laplace transform of sin at is equal to a divided by s square plus a square. Now third one is Laplace transform of cos h at, and fourth one is sin h at. Laplace transform of cos h at. We know that cos h at is equal to what? E raised to at plus e raised to minus at divided by 2. Then Laplace transform of cos h at is equal to what? Laplace transform of 1 by 2 into e raised to at plus e raised to minus at. By linearity theorem, this becomes half into Laplace transform of e raised to at plus half into Laplace transform of e raised to minus at. That is half into Laplace transform of e raised to at is what? 1 by s minus a plus 1 by 2 into Laplace transform of e raised to minus at is 1 by s plus a. So we get half into cross multiplying each other s plus a plus s minus a divided by s minus a into s plus a, that is s square minus a square, a minus b into a plus b form. So what we get, a will cancel, that is 2s divided by 2 into s square minus a square, that is s divided by s square minus a square. So Laplace transform of cos h at is s divided by s square minus a square. Here s plus s is 2s, 2 and this 2 will cancel each other, remaining is s divided by s square minus a square. The fourth one is Laplace transform of sin h at. What is sin h at? E raised to at minus e raised to minus at divided by 2. By the linearity theorem, then Laplace transform of sin h at is equal to what? Laplace transform of half into e raised to at plus e raised to minus at is equal to half into Laplace transform of e raised to at plus, minus half into Laplace transform of e raised to minus at, that is 1 by 2 into Laplace transform of e raised to at is 1 by s minus a minus half into 1 by s plus a. Laplace transform of e raised to minus at is 1 by s plus a, that is 1 by 2 into s plus a minus s minus a divided by s square minus a square. So what we get, a divided by s square minus a square. S and s will cancel. Here a minus a is 2a. 2a divided by 2. A divided by s square minus a square. So Laplace transform of sin h at is a divided by s square plus s square minus a square, and Laplace transform of cos h at is what? S divided by s square minus a square. Thank you.